Hello everyone. Today's problem is about minimum operation to reduce x to 0. So basically what we have an input, an array of integer, and we have a target element which is x, and we are supposed to find out how many element minimum we can remove in the inputs array in such a way that we reduce this to 0. Let us take this one for instance. We have is equal to 5, right? If you remove 5, if you remove 3 from 5, you are going to have 2, right? If you remove 2 again, you are going to have 0. So that is a valid operation. Another way of doing it is to remove the 3 and remove 1 and 1. But the issue is that this actually solution result into removing 3 elements, which is bigger than the previous one. So the previous one is actually the solution we want. So now, given that, how are we going to approach it? A better straightforward approach of solving this will be to consider removing the longest subarray in such a way that the rest of the element will actually have a sum of this. Because finding the longest subarray can easily be achieved using sliding window. So that is how we are going to operate to solve this. So what will our solution look like? So basically, we are going to create a target sum, which would be the sum of the longest subarray, because as we just said, the subarray is actually the array in between it's actually the array where the sum of the rest of the element will be equal to x. That means our target element, that means the subarray, our target sum, that means the sum of the subarray will be equal to the sum of the array minus that target minus x. And then after that, we compute array size because we are going to use it many times, so we just store it to avoid computing many times. Now we compute the max length. The max length is actually the length of the element, like the max length of the subarray respecting this. We initiate it at -1 and then we are going to update it while moving. Now we have a current sum. That means the sum of the element in our range from the left pointer to the right pointer. We initiate it at 0 because we want the left pointer to be 0 and we want to start the right pointer at 0. So now that we have those two elements, we can now loop. So basically the idea here is to move the right pointer until the sum of the element from the left pointer to the right pointer exit the sum. And once it exits the sum, you now move the left pointer to make sure that you now move the left pointer until it doesn't exit anymore, and then you check if it is equal. I'm going to have a simulation at the end. You're going to understand it better. So for each of the elements, you move the right pointer one step forward, and after moving one step forward, you actually need to increment the current sum to be aligned with what we are doing. And once it has increased, when the current sum had been increased, now you need to check, is that current sum actually greater than our target sum? Yes. If it is the case, what we are going to do is that we are going to try to move the left pointer until this condition is no more respected. If the condition is no more respected, we now need to get out of the loop. Now, by getting out of the loop, do we have a current sum which is actually equal than the target? If it is the case, we now check, does the right pointer minus the left pointer plus 1. This is actually the formula to compute the number of elements between two elements. So the number of elements between the left and the right is actually the right minus the left plus 1. If that number of elements resulting into this sum is actually greater than the previous max, then this max will take this one, otherwise it will remain with the previous value. And then at the end we just return this. So given this, let us run and see what it gives. We have everything green. So this was my approach of solving this. I hope you do enjoy it. Feel free to leave me a message in the comment section, and then here's the simulation of the thing. Take a look and don't hesitate to give me your feedback on it.